Hey, so welcome back to my part 2 for my function transformation based questions. I found another interesting question. This is a bit of a higher level question, so I'll be showing step by step, especially for part D, which is actually quite unique. It's in the inverse of what we usually get for our other patterns. So then let's start off with the question. So we have f of x is equal to 2x minus 1 whole squared minus 8, for which x belongs to all real numbers. So we know this is in vertex form. So our first part A wants us to convert and prove that the standard form of this function is 2x squared minus 4x minus 6. So let's open up and simplify our function. So basically 2 into x squared minus 2x plus 1 minus 8. So this will become 2x squared minus 4x plus 2 minus 8. So in the end this will become 2x squared minus 4x minus 6. So therefore f of x is equal to 2x squared minus 4x minus 6. So now for part B, we need to look for the coordinates of the vertex, write down the y-intercepts, and find both the x-intercepts. So we know from our vertex form, which we have over here, we can find the vertex. So for part B, so we know we see a minus 1 over here. This minus 1 will become a 1, so h is equal to 1. And this over here is nothing but a k. So we know that in vertex form is x minus h plus k, where h's sign, the sign for h is always the inverse of what we actually see. So therefore the coordinates for our vertex is nothing but 1 comma minus 8. So now we come to part 2, which wants us to find the y-intercept. For looking for the y-intercept, we'll be using the standard form because it makes our life easy. So we'll say 2 into 0 squared minus 4 into 0 minus 6 is equal to our y-intercept. So essentially our y-intercept is equal to minus 6. So the coordinates for our y-intercept are nothing but 0 comma negative 6. So now we come to part 3, which wants us to find both the x-intercepts. So to do this, we can basically equate our standard form 2x squared minus 4x minus 6 to 0. So now we can plug in the quadratic equation by 2a. So this is a quadratic equation. So if you plug our values in, we get 4 plus minus root of 16 plus, because we have a negative 6 over here, 16 plus 4 into 2 into 6. So we basically have, and then this will be by 2 2s are 4. 4 plus or minus root of 16 plus 8 6 48 by 4. So essentially this will become 4 plus or minus root 64 by 4, which we can split into 4 plus 8 by 4 or 4 minus 8 by 4, which gives us x is equal to 3, or x is equal to minus 1. Therefore the coordinates, the x-intercepts, are x is equal to 3, x is equal to minus 1, where the coordinates are 3 comma 0 and minus 1 comma 0. So this is part B solved. Now we come to part C, which wants us to sketch the graph of f. But when we're sketching a graph, we don't have to pay attention to the actual symmetrical aspects of the graph, but instead we have to mention the main and the important points. So yeah, I'll just draw the graph and come back. Yeah, so here's my graph. The graph might not look symmetrical, but it should be fine as long as we mention all the important points on our graph. So basically we know the vertex of our parabola is 1 comma negative 8. So if we take that, this should be our vertex. Now we also know the h is nothing but our axis of symmetry. So our equation of axis of symmetry is x is equal to 1. Therefore we can draw a dotted line like this. We also know the x intercepts are negative 1 and 3. Additionally, we also know from a previous subsection that negative 6 is our y-intercept. Therefore, with all these important points in mind, we can just draw a parabola. Here. So this is nothing but f of x. Now let's move to our last subsection, which is part D, which the question is basically, let g of x equal to 6x squared. Okay, for x is all real numbers, belongs to all real numbers. The graph of f may be obtained from the graph of g using the following two transformations. A compression of scale factor a in the y direction. This basically means that there is a vertical stretch by the factor a. We know it's a vertical stretch because a is positive. And we have a translation by the vector hk. Okay, so first let's write down g of x is equal to 6x squared. And we know f of x is nothing but a vertical stretch of g of x minus 1 minus 8. Now how do we come to this? So from our previous vertex form which we got at the start of the question, we know that f of x is x minus 1, 2 into x minus 1 whole squared minus 8. So essentially we are moving 1 unit to the right and 8 units down, so which is a h and k. So from g of x we had a vertical stretch, and then we moved 1 unit to the right and 8 units down. So we can also equate this to a into 6x minus 1, which is 6x squared becomes 6x minus 1 whole squared minus 8 has to be equal to 2x squared minus 4x minus 6. So if we further simplify this, we get 6 into x squared minus 2x plus 1 minus 8 is equal to 2x squared minus 4x minus 6. Then a into 6x squared minus 12x plus 6 minus 8 is equal to the same thing. So now we can write down 6ax squared minus 12ax plus 6a minus 8 is equal to 2x squared minus 4x minus 6. Now this line might seem intimidating, but from here we can actually use quick mental math to figure out the solution. So what multiplied into 6 gives us 2? What multiplied into 12 gives us 4? And what multiplied into 6 and after multiplication subtracting 8 gives us negative 6. So there's only one possible answer, which is 1 by 3. When you multiply 6 into 1 by 3, we end up with 2. When we multiply 12 into 1 by 3, we end up with 4. And finally, when we multiply 6 into 1 by 3, we end up with 2, which is subtracted from 8, which is equal to negative 6. Therefore, a is equal to 1 by 3. And from the previous abbreviation, we can also tell that h is equal to 1 and k is equal to negative 8. So thus we answered the final question, which was find the values of a, h, and k. So we can put this in the form of a therefore statement, and we can say a is equal to 1 by 3, h is equal to 1, and k is equal to -8. So that's it for the transformation based questions for functions. I feel like as long as you understand the basic concept and what actually goes on between the functions and their transformations, you can easily solve any question which comes under this topic. So I hope you learned a lot today, and have a good day. Thank you.